Section 3.5, we're going to continue with direct variation, but this time we're going to look at the nth power. So sometimes you may have direct variation where it says that it's a square or it's a cube of something. And here's an example of that. The area of a circle. The area of the circle is directly proportional to the square of the radius. And so if you had read it this way, you know that A equals something times the square of the radius. This pi is your constant of proportionality, your K value in this case. So if you hear that y is directly proportional to some nth power, it could be squared, it could be cubed, it could be to the fourth. After that, they usually just say it to the fifth, the th of something. And then you would put y equals kx to the nth power. So here's an example. We have a distance of a ball rolls down an inclined plane is directly proportional to the square of the time it rolls. During the first second, the ball rolls 8 feet. Write an equation relating to the distance traveled to the time. And then how far will the ball roll after the first 3 seconds? So here's our first equation. We know that d is your distance and t is the time. So we're going to say d equals kt, and we know it has to be squared, so it's t to the second. We have d equals 8 and t equals 1. So we're going to replace those in our equation so that we can solve for k. So 8 equals k times 1 squared, and then you know that k is 8. Now we're going to rewrite our equation, replacing the k in our original equation, and that is d equals 8t squared. The next part of the equation said, the question said, what will the distance be after 3 seconds? So we're going to replace the t with 3, and when we do that, we find that it is going to be 72 feet. So in the examples, the direct variation are such that the increase of one variable corresponds to the increase of the other. So if one is going up, the other one is also going up. That's why it's called direct variation. And sometimes it could be both decrease.